Today I would like to discuss the DSC, Differential Scanning Calorimetry, is a device which is used to determine the thermal analysis of a material to evaluate the properties of the material and the thermal evaluation and the thermoanalytical analysis. In the field of orthodontics, before start of the treatment, how does the arc wire works? So there are the two possible options. One is at deployment of the arc wire at room temperature or oral temperature, means human body temperature. So in this analysis, we differentiate two curves. One is the cooling curve and the heating curve. Cooling curve gives the information of the Martensite start and Martensite finish, as well as heating curves gives us the information of the Austenite start and Austenite finish. When we this experiment executed with the help of nitrogen gas and nitrogen liquid. Nitrogen liquid used for cooling purpose and nitrogen gas for heating purpose. So after completion of the experiment, we analyze and highlight the curves on the basis of the Martensite finish and start, as well as Austenite finish and start. So Austenite finish and start gives us information that the temperature which associate with the oral temperature or human body temperature or the room temperature, and it categorized the, if it above the room temperature, its effect would be different. If above the human body temperature, its effects vary. So there is a different scope of the discussion where the Austenite finish temperature versus the super elasticity of the nickel titanium arch wire. So we will proceed this experiment physically on DSC. I start from the sample, how to preset the values of software, and then physically how to put the sample on the DSC pen and how to measure, and so I discuss consequently in stepwise for further proceeding. Differential scanning calorimeter. So before start to the DSC proceedings, we must on the nitrogen gas valve from here, and when it's on, basically it's controlled from the central. Now I switch on the nitrogen gas, and here first of all I open the Q series Q201875. Here I have to set the summary procedure. So mode is the standard, test is the custom, and sample name. So must keep in mind that before proceeding of the DSC test, the sample should be weight. Like in my case, weight is 6.86 milligrams. So keep in mind the standard, or you can say the optimal weight range is from 5 milligram to 20 milligram. That should be lie in between 5 milligram to 20 milligram. So weight is 6.86 milligram. 6.86 milligram. So DSC type. So here I have to generate the folder. This folder, let's say Asad Munir. I create a folder, because after analysis, for the analysis we have to need this folder, because our three files will be saved here. One is the text file, one is the PDF file, and so on. Okay, so file name should be 5:20 45 minute. Okay, so set all here, just focus. This is the most important. This is the flow of the nitrogen gas, that is should be around 50 milliliter per minute, and method time it's automatically, or you can say inbuilt. These are the actually running segment description. Number one is the equilibrate at 100. Second is cooling from 100 to minus 100 centigrade, but the standard rate of cooling is 10 centigrade per minute. Then it reaches at minus 100, we stop the cooling and again heating from minus 100 to 100, and then its loop will be finalized. So before going to this, reset all runs, and then we have to go for the running. This is the reference pen and this is the specimen pen. So I have to put this in specimen pen here. The length of this specimen is 2 mm to 3 mm. The wires should be touch the bottom of the pen. So I put on the specimen. Okay, so now cover with this tab, number 1, and number 2 is this. So cover this. So this is our DSC setup is now ready to run. I click the run. You can see here the first is the basically equilibrate. Okay, this curve is going to be start, and when it reaches at 100, because already its temperature is around 50, because our sample is ongoing. So meanwhile we have to move, and this is our nitrogen liquid. This is nitrogen liquid for cooling purpose. So you can operate it manually, but for the sake of convenience we made this electrical setup to move it. Here I want to mention there are two signs. This is 1 and this is 2. This is for downward of the tank. Okay, so when it pours the nitrogen liquid into the jug, so I stop here and slowly, because I have a control in my hand, you can see for the safety purpose you must wear the glove. So close again. Now move to the here. Here now our temperature reaches 96.97, and we have to reach equilibrate at 100. Equilibrate at 100. So also we have to notice here, then this arrow moves toward here from 1 point to this. So I'm waiting for this stage. As temperature reaches to 100, this our arrow moves to the point 2 where our cooling will be start. Okay, so this is actually equilibrate. This is our heat flow and this is our temperature. Okay, yes, moved. So now our cooling time starts. Put side on this, and this is on. This is our cooling. So continuously we have to pour this nitrogen liquid for the cooling purpose till our curve reaches at minus 100 centigrade. So this should be above than half level of this cup. Segment time this, remaining running time this, temperature is now this, heat flow is this, and like this. And must keep in mind that the nitrogen flow is should be around this. Okay, so this is curve. When it reaches at -100, we can monitor in the form of digital, in the form of digits here, like 82.63, and here then temperature will reach at -100 centigrade. Then again we have to stop cooling and put the this one heating. So in this way our cycle will complete. So here we are continuously monitoring our cooling curve. Now it's reached around -95. So when it reaches -100, or this arrow here, this arrow moves toward this. I mean that now at this stage we have to stop the cooling. Cooling mean we have to stop the nitrogen liquid pouring, and we have to take up the cup of the cooling. Let's see here. You can see you must wear the glove and take up this here and put up this one here. So our heating phase starts again. If extra nitrogen liquids you put into the glass and put into the mantle, because due to volatility of the nitrogen liquid, we must save into the nitrogen liquid tank. So when it reaches to 100, so for this purpose you can say it takes around 20 minutes, because rate of cooling and rate of heating is 10 centigrade per minute. So -100 to 100, it takes 20 minutes. We move toward the analysis. 5:20, 45 minutes. Here first of all we have to recheck again size, operator name, etc. So okay, so this is our analysis curve. So first of all go to here, integrate peak linear line, integrate peak linear line. So click here. We have 2 points. These are the two curves here, and this is the basically you can say peak, where we can highlight our 2 points. This is the upper is the cooling curve. So this is our Martensite and this is our Austenite. So for the analysis more, we go to the analyze, go to the option onset and tick the manual. Okay, so again this, so here you click it and this and these 2 points and enter the values. So 1 year overlapping, delete one label. So we highlight our analysis of the Martensite, Martensite and finish here. So in cooling curve there are the 2 peaks. So we have highlight 2 peaks similarly like this one. So again option onset. Now first we have to do with the not manually. So here here and this one is the here. So move toward, actually our peak start from here. Okay, so enter and then again go to analyze, option onset, manual. Okay, and this one click. So here these are 2 points where our Martensite finish. Okay, so we delete one, and here is it. So here is the basically you can say heating curve. Though we similar, just analyze, option, onset, manual. Okay, here. So this Austenite start, this is the Austenite finish, enter, again go to analyze, onset, manual. Okay, here, and so this is Austenite finish. So we have to highlight these 2 points. So delete the label. So in this way our analysis complete. Here you can see that the thermal transformation of the material with the help of heat flow and temperature. So this is our cooling curve. This is the Martensite description on 2 points. Here is the Austenites. So here is the Austenite finish is 41.58. okay, so we save how to save this. Save analysis, not analysis, you can see analysis and data. So 540, and here where is our 520 folder, this, open, save. Okay, and again we have to say export data file and plot signal. Okay, finish, and here you add the word text, because for Excel graph you need to this text. So save. So in this way our analysis completes. Thank you so much.